Hello kids, welcome to ICSE Chemistry Hub. If you are worried about your chemistry board exams, then this is the correct place where you can reach out to. Because here, all the chapters will be tailor-made for your exams. When I'll be teaching, I'll be also explaining what type of questions can come from that particular chapter. I know many of you are viewing my videos, but please do like and subscribe the channel so that you can get a notification whenever there's a new video that is uploaded here. So please do like and subscribe the channel, children. Moving ahead, today we will be doing part 4 of electrolysis. We have already done 3 parts of electrolysis. If you have not viewed that, this description will be there. The links will be there in the description box. Kindly go through it once again. Also, please do keep on repeating the videos, see the videos, and keep on writing it so that you are thorough with this chapter. So today we'll be dealing with part 4 of electrolysis. This is a very, very important topic for your board exams. Many questions are asked from this part of the chapter. So today we are going to deal with electrolysis of one of the most important compounds that is asked in the board exam. It is nothing but the electrolysis of aqueous copper sulphate. Children, the formula of copper sulphate is nothing but CuSO4. Can you tell me what is the color of copper sulphate? Yes, the color of copper sulphate is blue in color. Now please remember, this blue color of copper sulphate, the cation that is responsible for it is Cu2 plus ion. So please remember this throughout the chapter, that whenever we are doing electrolysis of copper sulphate, if they ask you in the exam which is the cation that is responsible for that blue color, that the beautiful blue color that copper sulphate gets, it is Cu2 plus ion. So today we'll be doing the electrolysis of aqueous copper sulphate. Now I have already told you, whenever we are doing electrolysis, we can never do electrolysis in the solid state. We always need to do it either in the solution state, or I need to do it in the fused or the molten state. So when I get copper sulphate, CuSO4 is usually in the solid state. It's a very, very beautiful blue color solid. But I cannot do electrolysis on solid copper sulphate. So the best thing that I do is, I take copper sulphate as an electrolyte, but I have to add one another thing inside it. What is the other thing that I add? I have to add water inside it. So there are 3 things that basically goes into this electrolyte. 2 things I have already told you. I will take copper sulphate, that is CuSO4 will be my electrolyte number 1. Into this, I will add the next substance, that is nothing but water. Clear? And into it, I will add one more substance. I will add an acid, which is the acid that I will be adding, children, just like when I did the electrolysis of water. Clear? I had added a few drops of an acid. And which acid had we preferred, children? We had preferred H2SO4. H2SO4 is nothing but sulfuric acid. So why I'm adding this, I'll get into it a little later. So into this substance, whenever I'm doing electrolysis of copper sulphate, I'll be adding 3 things inside it. What is the number 1 thing I'll be adding? Of course, I need copper sulphate. I have to make a solution of it, so I will be adding water. Into that, I'll be also adding a few drops of an acid. Which is the acid I'll be adding, children? Yes, I'll be adding sulfuric acid. Now, the question here that is mostly asked is, why am I adding sulfuric acid into my electrolyte? There are basically 2 reasons for this. I'm adding sulfuric acid because when I add sulfuric acid into my electrolyte, it will increase the conductivity of my electrolyte. It will increase the conductivity of CuSO4. Can you see here, children? It enhances the conductivity of my electrolyte. It will allow huge amount of electric current to pass through my copper sulphate when I add just 1 or 2 drops of sulfuric acid. Clear? So this is the major reason why I'm adding copper sulfate. Secondly, it prevents the breaking of water that is there in the electrolyte. I need water to break, but this should not be the major reaction that should be happening in my electrolyte. The major thing that I need to break is copper sulfate. Clear? So what are the two reasons why I added sulfuric acid or why I carried out acidification of copper sulfate? The major reason is because it increases the conductivity of the electrolyte and it prevents hydrolysis. What's the meaning of the word hydro? Hydro means water and lysis means breaking. Clear? So it prevents the hydrolysis of the electrolyte. So this is how basically my setup for electrolysis of copper sulfate will look like. As you can see, I have a voltameter, or what is this called as? This is called as an electrolytic vessel. So I have taken my electrolytic cell or electrolytic vessel or voltameter. Into that I have put my electrolyte. Clear? Electrolyte is my copper sulfate. But is copper sulfate alone, children? No, it is not alone. I have also added two things. Can you tell me which are the two things? I have added water and I have also added one more thing inside it, that is a few drops of a sulfuric acid. Clear? Now I have taken two plates here. When you have a look at the diagram, children, you will be seeing here, it is electrolysis of copper sulfate using what kind of electrodes, children? There is a speciality in this electrodes. If you do not know, you can just go back to my previous videos and have a look. I had told you that copper electrodes, there is a very special thing about them. What kind of electrodes are these? These are nothing but they are active electrodes. And what do I mean by active electrodes? That means they themselves will start taking part in the reaction. Clear? So they will not be acting as mere spectators in the reaction. Their only work is not to get the ions discharged. Instead, this anode and cathode are made up of copper. So when I tell it is made up of copper, anything that is made up of C and S. What is C? Copper. N? Nickel. S? Silver. So anything that is made up of copper, nickel and silver will be called as active electrodes. And what do I mean by the word active electrodes? They themselves will start taking part in the reaction. So this is the speciality of this electrolysis and this is the reason why it is mostly asked in the exam. Clear? So I will have two metallic plates. One is cathode. What is my cathode made up of? Yes, it's made up of copper. Again, I have my anode, which is again made up of copper. So I have my active electrodes that are placed. Active electrodes means they themselves will start taking part in the reaction. So now I'm going to start with the reaction part. Please look into this very carefully. So when I do electrolysis of copper sulfate, using what kind of electrodes, children? I have used copper electrodes. Yes or no? And what is the speciality with copper electrodes? When I say copper electrodes, I mean these are active electrodes. What do I mean by the word active electrodes? That means they themselves will start taking part in the reaction. So first we will write the general reaction. What is the first substance I have added? I have added CuSO4. How will this decompose? How is this compound going to break? It will break as Cu. What is the valency of copper, children? We will take it as Cu2 plus. Plus what is remaining here? Yes, I have an SO4 minus ion. But what is the valency of a sulfate ion? I will get it as SO4 2 minus. So CuSO4 will decompose to give me Cu2 plus SO4 2 minus. This will be my decomposition reaction for the first thing that is there in my electrolyte, that is copper sulfate. But did I take copper sulfate alone? No. I have taken one other substance, that is nothing but water. How will my water decompose, children? We know whenever water decomposes, it will decompose as H plus OH minus. So how many H's are there? 2H, and there is one O which I have written here. So please remember, water decomposes as H plus and OH minus. Did I add something else also into the electrolyte? Yes. If you remember, I had said that I have acidified copper sulphate. What do I mean by the word acidified? Acidified means I have added a few drops of an acid. So this sulfuric acid that is there in the electrolyte is also going to be decomposed. So how many H's are there, children? As you can see in the reaction, 2H. Yes or no? Here you have H2. Write it. When it decomposes, it will give you 2H1 plus. Clear? Plus, it is again going to give me which anion? SO4 2 minus. So can you see in this reaction, in the electrolyte, I will have two cations. Which are the two cations? I will have Cu2 plus and I will have H plus. So which are my two cations here, children? I will have Cu2 plus and I will have H plus. Also, I will have two anions in my solution. Which are the two anions that I'll be having? I'll be having SO4 2 minus and I will be having OH minus, sulfate and hydroxide. Okay. So ions are formed. I have passed electric current. My ions are now ready. Ions are formed. Now what will be the next step? They will try for a discharge. What's the meaning of the word discharge? They want to get discharged. They want to lose their charge, or in other words, they want to get neutral. So ions will start running towards the respective electrodes. I will first start with the reaction at the cathode. So what is a cathode, children? We know cathode is, what is the charge that a cathode has? Cathode is negatively charged. And we also know it is C2C. What do I mean by C2C? Cations run and they go towards the cathode. Opposites attract. If cathode is negatively charged, I can be sure which ions will come towards it. It will always be the oppositely charged cations. So cathode is negatively charged. So C2C. Cations will run and come towards the cathode. But can you see here, children? There are two cations. I have cation number 1, which is copper. I have cation number 2, which is hydrogen. Both are competing. Both are having a competition for a discharge. So which one do you think you will get discharged first? Clear? If you remember something called, which I have taught as the electrochemical series. Do you remember this series? The electrochemical series will decide which one will get discharged first. Let us have a look through the electrochemical series for cation. What was the short form I had given you to remember? Please send cats, monkeys and zebras into lovely hot. Hot here stands for hydrogen. Countries stands for copper. And we know, so hydrogen comes at the top, copper comes just below it. And we know that lower the position of the cation, more quicker is the discharge. Am I clear? So more lower the position of the cation in the electrochemical series, the more quickly will be the discharge. So amongst hydrogen and copper, which one do you think will get discharged first? Yes, it will be the copper cation. So Cu2 plus wins here. Why? Just because it is placed lower in the electrochemical series. Clear? And we know, do you remember the short form that I have given you? CGR. That means cathode. What happens at the cathode? It gains electrons. And we know whenever any element gains electron, what is the process that we call it as? Reduction is nothing but gain of electrons. Clear? So at the cathode, what reaction is going to happen? It is always going to be cathode will gain electron and it will undergo the process of reduction. So even if you don't understand this, just go through the flow of the reaction. Cu2 plus. If it's a plus here, what sign will come here? Here also will be a plus sign. What's the number here, children? Here it is 2 plus. I will also write here 2 electron. Clear? So Cu2 plus. I'll also put a plus here, 2 electron. Clear? What will I get? I will get a neutral copper atom. We can also call it as copper metal. Clear? So please have a look at this, children. Cathode gains electron. So cation is having 2 plus. So it will gain. When I say gain, it is a plus sign here. If it has lost 2 electrons, I am giving it 2 electrons. Plus means it has lost electron. So I am giving it 2 electron. Now it has become neutral copper metal. Clear? Now you have to remember what is the color of copper metal, children. Whenever this comes as an observation based question, what is the color you have to remember? It is a reddish brown color metal. What is the color of copper metal, children? The color of copper metal, it is a reddish brown color metal. Or board accepts one other color that is called as pink. So please remember, whenever at the cathode copper metal is deposited, here I have my copper. So whenever this reaction is happening, what will start happening at the cathode? Slowly at my cathode, copper metal is going to come and it is going to get deposited on the cathode. So what color will you observe? You will observe a reddish brown, or you will get a pink color metal deposition on the cathode. So this will be my first observation. Am I clear, children? When copper metal is deposited, neutral copper metal is deposited at the cathode, the first observation that you will get is a reddish brown color metal or pink color metal will be deposited at the cathode. Also, can you see, when this copper metal is coming and depositing at my cathode slowly, what is happening to the thickness of the cathode? Can I say that the mass of cathode increases? So this is a second important observation that you have to remember here. Clear? So what are the two important observations that you have to remember, children? Please remember, cathode, at the cathode cations will come. Cations will gain electron. Gain means plus. Whatever number is here, you blindly copy it here. So 2 plus, I will write plus 2 electron. It will become neutral copper metal. Clear? So where will this copper metal start depositing? This copper metal will start depositing slowly on my cathode. So what kind of deposition will you be able to see? You will be able to see a reddish brown color metal, or you will be able to see a pink color metal. Also, please do remember what starts happening to my cathode. Because the metal is getting deposited, the mass of the cathode, the size of the cathode will slowly start increasing. I hope this is clear to you. Okay? So can we go ahead with the reaction at the anode? Now, anode is having what charge, children? Anode is positively charged, yes or no? So opposites attract. It will be A to A. Clear? So when I have a look here, anode is positively charged. So anions will start moving towards the anode. Oppositely charged. Clear? Anode, anions will go. Here there is again a competition. CuSO caliber IO. CuSO is sulphate, IO is hydroxide. Which one do you think will get discharged, children? The lower the anion is placed, more is the chance of it getting discharged. But here you have to remember a very, very important thing. This is a mistake that most of the children commit in their board exam. Clear? They just go by the flow and they write that because OH is placed lower, it has to be discharged first. But can you tell me, children, which kind of electrode have I used? Please remember, I have used copper electrode. What is the speciality with copper electrode? Copper electrode is an active electrode. So please remember, neither sulfate will get discharged nor OH minus will get discharged. Clear? Actually, it should have been hydroxide. But please remember, whenever we use an active electrode, anything amongst copper, nickel and silver, whenever you use, neither of the anions will get discharged. Instead of that, the metal itself at the anode. What metal have we taken at the anode, children? We have taken copper metal at the anode. It itself will start taking part in the reaction. Am I clear? It itself will start breaking and falling into the solution. Let's see how this happens. Clear? I hope till here it's clear to you. Okay? So coming back to the slide, I told you at the anode, because anode is positively charged, anions will run and come towards it. But will SO4 get discharged? No, no chance. Actually, it should have been hydroxide. But does hydroxide get discharged? No. That also does not get discharged. Why it does not get discharged? Because I'm using an active electrode. Which is an active electrode I'm using, children? I'm using copper electrode. What is the speciality with copper electrode? It is an active electrode. Clear? Now here you have to pay attention how we are going to write the reaction. Do you remember the short form that I had given you? ALO. What is the meaning of the word ALO? Anode. At the anode, what is going to happen? It is going to lose electron, and what process is going to happen here? Oxidation is going to happen. So please remember this, children. An anode loses electron, the anion will lose electron, and what process happens here? Oxidation will start happening. Clear? So let us start with the reaction. Which is the electrode that I have taken, children? I have taken copper electrode. Copper electrode is what kind of an electrode? It's an active electrode. That means it itself will start taking part in the reaction. Just follow this short form. Anion loses. So when I say loses, what sign will it get? Minus? Yes or no, children? If it is losing electron, what sign will it get? I'll put a minus. It loses electron. How many electron does it lose? It loses 2 electron. And what will it form, children? Now I know whenever any metal loses electron, whenever it donates electron, whenever it loses electron, what sign does it get? It gets a plus sign. And what number will come here? It has lost 2 electrons. Anion has lost electrons. Yes or no? So Cu minus 2. So if it is lost 2 electron, what sign will come here? You will get a plus sign here. Am I clear? So this is nothing but what has been formed here. We call it as copper. We call it as copper. Just a minute. I'm so sorry. What is formed is copper ions. Am I clear? So can you see the difference here? At the cathode, what am I getting, children? At the cathode, my metal copper is getting deposited slowly onto the cathode. Clear? I am getting neutral copper metal. But at the anode, please remember, none of the ions get discharged. Neither SO4 gets discharged nor OH minus gets discharged. Clear? Instead, the metal itself will start taking part in the reaction. So what happened? Copper loses electrons. So when I say loses, it is minus. It will always lose 2 electron. When it loses 2 electron, what sign will it get? It will get a plus sign. And what we know, what is this Cu2 plus called as? This Cu2 plus is called as copper ions. Clear? So I am once again telling the reaction. Please pay attention to it. Clear? So I have taken copper sulfate. Yes or no, children? So my copper sulfate decomposes to give me Cu2 plus plus SO4 2 minus. Second thing that I have taken is water. How will my water decompose? H plus OH minus. H2SO4 will decompose as, how many H's are there? 2H plus and SO4 2 minus. Clear? So look at the reaction, children. Electrolysis of copper sulphate is happening with copper electrodes. What all ions are present in my electrolyte? In my electrolyte, I have Cu2 plus, I have SO4 2 minus, and I have H plus, and I have OH minus. So I have 4 ions that are present. Which are the 4 ions, children? Copper, hydrogen, sulphate, hydroxide. Clear? Coming at the reaction at the cathode. What happens at the cathode, children? At the cathode, there is a competition between copper and hydrogen, which will be selectively discharged. Which one will be given a preference? Of course, it is my Cu2 plus. If it is a plus here, put a plus here, 2 electron, what will I get? I will get copper metal. That is a reddish brown colored deposit. So what will start happening at my cathode, children? Slowly at my cathode, you will find that copper metal is slowly getting deposited. So in short, I will get a reddish brown deposit. Clear? Reddish brown metal is deposited. What's the second observation you will see? You will also find that the mass, can you see here, children? The size of the cathode is slowly increasing. So remember the 2 important observations at the cathode. Copper metal, you will not write it just as copper metal. Please do write it reddish brown color copper metal is deposited, or pink color copper metal is deposited. What starts happening at the cathode? At the cathode, there is an increase in the mass. There is an increase in the size of the cathode. Please do remember this. Clear? And why is the size increasing? The size is increasing because, as you can see here, copper metal will slowly start coming and it will start accumulating at the cathode. Am I clear, children? Okay. Moving on towards the anode. At the anode, there is a competition between SO4 2 minus and OH minus. Neither SO4 2 minus will get discharged nor OH minus will get discharged. Why? Because what kind of electrode have I used? I have used copper electrodes. Clear? So it itself will start taking part in the reaction. It will itself take part in the reaction. So at the anode, there will be a loss of electron. So whenever it's a loss, I'll put a minus. How many electrons will it lose? 2. We know whenever any metal loses electron, what sign will it get? It will always get a plus sign. So which ions will be formed? It has lost. So plus, how many electrons has it lost, children? It has lost 2 electrons. Clear? Now please have a look at this diagram. Clear? What is happening here? At my anode, I have copper metal and it is what kind of an electrode? It is an active electrode. So please remember this. My anode is slowly breaking down and it is falling down into the solution as Cu2 plus ions. Clear? Because ions can remain independently only in the solution state. Clear? I am once again telling you what is happening, children. At my cathode, there is copper metal deposition. Clear? The mass of the cathode is increasing. Come to the anode. At my anode, what is happening? My metal itself has started taking part in the reaction. It is breaking and it is, so this anode has slowly started breaking and it has started breaking and forming Cu2 plus ions and it is falling down into the solution. Clear? So what will be formed at the anode? I will be getting Cu2 plus ions. Will you be able to see Cu2 plus ions in the solution, children? No. This cannot be called as an observation. Please remember it. Cu2 plus ions forming in the solution cannot be seen. You cannot write this as an observation. Please remember it. But if it is asked as an observation question, you cannot write this as an observation. I hope I'm clear with this. Clear? Then what will you write down? I just now told you anode is breaking and it is falling down into the solution. So can you tell me what happens to the mass of the anode? If anode is breaking and it is falling down into the solution, of course it must be decreasing. Clear? Why is it decreasing? Because my anode is breaking down and it is falling down into the solution. So please remember, what is the observation you will write at the anode? At the cathode, reddish brown deposit is formed and the mass of the cathode increases. Clear? But at the anode, please write Cu2 plus ions are formed. Correct. This is a correct product that is being formed. But please do not write this as an observation. Clear? You can either write no product is formed or please use this sentence. If my anode is breaking down, if my anode has started falling down into the solution, I know for sure that the size, my mass, the size of the anode would start decreasing. It will start reducing. So what is the observation you have to remember here, children? That the mass of the anode will start reducing. The size of the anode will start decreasing. I hope this is clear to you. Okay. So can you see here, children? Copper anode shows a loss in mass. It decreases in size. Clear? Now one last thing here, children. This is one of the most important questions. So please do not skip this video. Watch it till the very end and please keep on seeing it. Clear? The most important question that they will ask you is, when we are doing electrolysis of aqueous copper sulfate or copper sulfate solution, why doesn't the blue color of copper sulfate fade? Okay, they will ask you why the blue color of copper sulfate solution does not fade. But it does not fade when you are using only and only copper electrodes. Throughout the experiment, my copper sulfate solution will always be blue in color. For 1 second also the color won't change. Clear? So you have to write the answer in 2 points. What is the first point you have to remember? Whenever I talk about copper sulfate, the blue color is because of cations. Clear? Which is a cation that is responsible for this blue color? It is my Cu2 plus cation. Am I clear? So as you can see in the slide, blue color of copper sulfate is because of the presence of Cu2 plus ions. Clear? So whenever I am doing electrolysis of copper sulfate using copper electrodes, remember one line. The concentration of Cu2 plus ions does not change. Am I clear, children? Please remember this sentence. You have to write this in the exam. What is point number 1 you have to write? A very, very famous board question that they will ask you. The point number 1 that you will write here is blue color. We know in copper sulfate, SO4 does not play any role in that blue color. Clear? Which is the cation that is responsible for blue color? It is Cu plus 2. Clear? Now, please look at this sentence very, very carefully. For every copper ion that is discharged at the cathode, we know at the cathode, what is happening at the cathode, children? Cu plus 2, it is getting discharged. What's the meaning of the word discharge? It is getting neutral. Clear? At the cathode, my cation wants to get discharged. So if it is a plus here, I am putting a plus here, 2 electron. It is becoming discharged. So for every copper ion that is discharged at the cathode, a new copper ion is formed at the anode. Agreed. Cathode is using up my Cu2 plus from the solution. Am I clear? It is using up my Cu2 plus. But at the very same time, what is happening at my anode, children? My anode, which is nothing but my copper metal, has started breaking and it is falling down into the solution. It is an active electrode. It itself will start taking part in the reaction. And we know it is ALO. Anode loses, how many electron will it lose? 2 electron. So when it loses, what sign will it get? Plus. So can you see here? At one place, my Cu2 plus is being used up. But at the very same time, one Cu2 plus ion is being produced. So please remember this. For every copper ion that is discharged at the cathode, a new copper 2 plus ion is falling down into the solution by the anode. Clear? So please remember this. The concentration of Cu2 plus never changes. Clear? Please remember this statement that the concentration of Cu2 plus never decreases. For every Cu2 plus ion, that is used up by the cathode, there will be a new copper ion that will be falling down into the solution. So at one place, at the cathode, my cathode is using up my Cu2 plus. Clear? But at the anode, what is happening? My anode is breaking and it is falling down into the solution as Cu2 plus. So please remember the overall concentration of Cu2 plus never changes. It remains the same. Am I clear till here, children? So this is all about electrolysis of copper sulphate. Please revise this very, very carefully because this will be for sure asked for the board exam. Clear? Thanks a lot, children, for viewing this video. Keep learning, keep revising, and please do come back. Please do have a look at my videos. Please do like and subscribe my channel. Thank you, children.